So in recognition that I stand between you and lunch, and to reward those of you who are on time, thank you. And let's go and get started. So my name is Mark Thompson. I actually work for Hewlett Packard. Hewlett Packard Enterprise, as we will be known after the company splits apart in November of this year. But I work in the networking business. So here to talk about mobility and the challenges and the changes you're going to go through as what we call the campus environment, the way we all connect to the network, goes through a lot of changes over the coming couple of years, starting probably a couple of years ago. So I'm sure many of you are feeling the pain already, and we'll hopefully paint the landscape of what you need to think about, how you need to go through that transition, or at least what you need to be prepared for as you do. So 3 big trends that are driving this change. We'll kind of check as we go through and see if you're feeling the impacts of these already. So the biggest one, the thing that has the biggest apparent change in the environment, is the demand from your users, demand probably from all of you, to be able to access everything you do in life wirelessly, right? We all get used to it at home. We all get used to it everywhere else we are. So when we come into work, why wouldn't we want to be able to move about, right? You want to work in something in the cafeteria, you want to work in something at somebody else's desk, wherever you happen to be, you want to be able to get it done. So being tethered by a wire is not a popular thing. We've gone through lots of iterations of how do we try to police that. So we'll talk a little bit about what's coming now with the change of high-speed wireless. Wireless to date has been treated as more of a convenience network. So what we'll talk about today is the reality that the wireless technologies that are about to hit us, starting literally this month, to start to roll out in the industry, give people the same kind of performance, the same kind of application response, being wireless as they have been wired. And as a result, you're going to see that maybe a little annoyance of people saying, I want to work wireless, become a tidal wave, because in certainly all their minds, the last of the issues have gone away. That will create a whole new set of issues for all of us in how we manage networks, how we deploy all this. So that's part of what we're going to talk about today. The next big challenge, we sometimes refer to as the headline challenge, right, is none of us want to be the person who was responsible for the network or the information data set that made the headlines of the local newspaper or the 10 o'clock news because you were hacked. Because somebody's private data was lost, somebody's emails were exposed, whatever the reason, right? You don't want to be the next Sony, you don't want to be the next Target or Home Depot, or we could all go down the list forever. So as we get more mobile, maybe not as, but in addition to getting more mobile, right, we're also needing to get more secure. And I know for a lot of people that seem like conflicting challenges. So we'll talk a little bit about how we get through that. And the last piece, that may be the newest for many of you, so we'll spend a little extra time at the end, is this notion of networks no longer being this static sort of black box that applications have no concept of what's going on or how they work. The era of software-defined networks or software-driven networks, where applications and networks talk to each other and figure out how to manage security, how to manage application performance, how to tune things so that the end user, whether it's your customer or the employees around you, have a better experience with whatever they're trying to get done. So just a quick test. So how many people have heard, thought about, explored software-defined networks before? That's about the normal percentage of our population. And okay, so good, we'll spend a little bit of time there. So let's start with mobility, right? It is the expectation. And I would venture to say the younger the crowd you work with, customers or fellow employees, contractors, the more of an expectation it is. Folks under 25 or so probably have no wired. Why would I ever have a wire, right? They've grown up in the untethered world, at home and at work. But for the rest of us old-timers, we also appreciate that flexibility of being able to move around. And so it's not just becoming a convenience, it is becoming the expectation for everyone you work with. And yet, it's not so simple, right? Historically, we have managed networks almost as 2 separate things. We thought about, the network was this wired infrastructure, right? We took care of it, secured it, configured it. And then there's this wireless thing that came along and sort of laid on top of it. And yeah, if people wanted to use it, they could, but we try to be real careful of, you can only use it with the, state-approved, company-approved PC. You had to have a certain software on it, only certain authentications could get on it. So how's that gone over with your customers, employees? Yeah, not so well. The expectation is that I bring in my phone, and if I need to sit, because my PC battery died while I'm in a meeting and I need to pull up a spreadsheet on my phone, I should be able to get on the company network. I should be able to get on the group network and get something done. Your staff that manages the networks has also probably gone from a 80% focus on the wired network, and yeah, we kind of keep the wireless as best we can, to at minimum kind of splitting their time. And you may already be one of those people whose priorities kind of shifted over to the wireless side as it's more of a challenge. The reality is we need to stop thinking about these networks as two different networks. They're really one, right? They're all there for the same purpose. They're there for getting access to information, providing a service, not to whoever the user is. So from this starting point of, well, I was used to work one way in wired, and then I had a different way in wireless, had one level of performance from an IT staff, I managed them differently. We are moving to this world where it's all one, where we manage them as one entity, one set of resources. The fact that that last leg happens to be copper or radio waves shouldn't matter. And from a user standpoint, I want to be able to flip back and forth. I want to be, if I'm wired at my desk, maybe I want to be able to walk around the building, right? I want to have that freedom to go wherever I want and not have my access rights, my performance levels, the applications I can use, or anything about my experience change, right? As a user of the network, my job is not to understand the network. My job is to understand my job, right? So they want to focus on what they do, leaving, that networking complexity to someone who sits in the back room. Part of our job is to make sure those highly valued people who sit in the back room trying to keep that network alive and running, right, have as easy as time as well. So as we bring the networks together, you will hear terms like unified wired and wireless, converged networks, single sign-on, the ability, people talk about even the ability to go back and forth. There's a technical term. This is that notion of you as a user connect however you want. We'll talk about what that means to security, what that means to applications in the remainder of this conversation. But start thinking of your network now as a single environment, right? I think so. This is one of the big mindset changes that the organization should have gone through already or should be going through right now. It is no longer I have a wired network and then I have wireless. I need to start thinking about this as one. And every time I have a conversation about what do users have access to, how is security provisioned, what's performance like, what applications need to consider, they need to think about the combination. Mobility, the term we use maybe historically to talk about wireless, is not just about wireless. I mean, in my daily job, I'll go from my desk to a conference room to somebody else's desk. I might be connected wired in all those cases, but I'm moving around. Then maybe the fourth time I open my laptop, I'm connected wireless. I expect it to work exactly the same way no matter where I am. The network to recognize me, applications to recognize me. So as you're planning for new applications, for new infrastructure, right, think about it as one. It is no longer a separate purchase decision, right? Your users expect it to all behave truly as one. One of the impacts you're going to see as you look at this combined network now is the speeds are going up. So as I said, the biggest change maybe we're seeing in the wireless environment now is speeds have gone from, again, kind of convenient speeds. Yeah, it's a little slower on wireless, but it's more convenient, so I'll make the trade-off. As we get to the new technology, 802.11 AC is the phrase you'll hear, right? That's the IEEE standard for high-speed wireless. So this is the ability to go at gigabit and higher as we go through time speeds. That performance increase is going to draw more people onto the wireless network. Good, it works faster. But now you're going to have the challenge of through the rest of the network, right? Where are the bottlenecks? So think about it this way. In the old days, today for most of us, 802.11n, that's what's deployed most places, right? Gigabit links ran from the access points, and you aggregated a bunch of those in a wiring closet, maybe you had 10 gigabit running up. Tomorrow, right, that's going to change to this mid.11 AC and its follow-ons. New technology being released because those access points can now run faster than a gig, right? So now that wire has become the bottleneck, going from the access point into the closet. So good timing by all of us across the industry, not just HP. The advent of 2.5 and 5 gig ports that run over the same wiring that people have deployed for current access points. So leave the wiring in place, you put new ports in the closet, new access points, and you don't have a bottleneck anymore. Until maybe you try to go out of the wiring closet, because I've got all these high-speed wireless users now trying to get out of the wiring closet. So the last piece you see up here is we shift from 10 gigabit going out of the wiring closet to 40 gig, right? Pretty mundane, it's the upgrades of speeds and feeds. But it is what people are going to expect as they try to take advantage of that high-speed wireless, right? It's similar to, roll the clock back a number of years to when we first got gigabit to the desktop, right? People got their first PC with gigabit to the desktop. The last thing they wanted to hear is, I just went out and got this fancy new toy that says it runs really fast, and it doesn't actually run any faster than the old one did, because there's a bottleneck somewhere else in the network. So I don't expect many of you or anybody, frankly, to go out and, well, let's just rip everything out and replace this overnight. But as we go through the natural evolution of replacing infrastructure, just the natural depreciation cycles and upgrade paths, you will see this multi-gig link. HP calls it smart rate. There's an IEEE standard in progress to make it all nice and interoperable across the industry. But you see this 2.5 and 5 gig link speed going out to access points, and we'll see 40 or even 100 as we go through time if you live in a very densely packed building with lots of wireless wiring closets. That campus network then in the end, right, as we get all these pieces pulled together, certainly converges at the access layer, but it's going to do more than that, right? So that's kind of the speeds and feeds, the easy part. We're all used to, we went from 10 to 100 to gigabit, and time marches on now to wireless and higher speeds. The rest of the solution here that we're going to talk about is about services and intelligence in the network, security capabilities, application capabilities that take the network from just a dumb set of plumbing and enable it to deliver those capabilities that all those users are actually looking for, right? They're not just looking for it to be fast, but they're looking for access to what they want, where they want, right, in the appropriate formats and sizes, et cetera. So your network, as we talk about security capabilities in SDN, is going to grow up from a dumb set of plumbing to frankly a very intelligent infrastructure that's engaged in dialogues with the applications and is really there to optimize the performance, the experience that goes on between the end users, their applications, and the rest of the environment. So let's transition real quick to security. So again, the headline test, right? Cybercrime used to be those things that, happened in the movies, that happened once in a while. That you had, I have a security guard at the front door. We have a secure building. We can't have anything stolen out of this building. Nothing could possibly go wrong here. Why would North Korea want to bother with our systems? We haven't done anything to them. Yeah, so those days are long gone, obviously. Right. Cybercrime, whether it's intentional or for fun, talk about both cases here, is something that all of us have to worry about now, right? It is the complexity that you live in fear of probably every day. The networks around the world are growing, right? Billions and billions of devices. We have to keep updating this slide every month or two because people's estimates of what 3 years out look like keep growing. Most infiltrations of your network today occur from your own employees. They don't know they've infiltrated your network. They didn't do anything on purpose, but they were surfing the web over the weekend and went to a few sites that maybe they weren't best advised to go visit. And lo and behold, their PC is infected. No, that can't be. I have antivirus software on my PC. Sure, and this is the next version of that hack or that malicious malware that antivirus software has no clue about today. They bring it back in the office, and lo and behold, it slowly starts creeping around the environment very carefully to the point where most people don't recognize that a bit of malware has been released in their environment. Statistics say it's an average of 146 days. We've seen customers, though, it's been a couple of years. We can trace back when the first infiltration of the network and it started to deposit little bits of code around the network to later assimilate itself. And some of these are done by people out to actually harm the business, right? They're actually looking to harvest data. They're looking for social security records, any personal information they can go sell out on the black market. Some of these are high school kids just looking to see if they can, right? Not the thing you really want to put on your resume when you're looking for a job later, other than maybe with a few government agencies back east that say, if you've done it badly, maybe you can do it for good. But it's coming from all sorts of places. And so you see across the industry now a lot of investment in trying to, catch up with these new threats, right? Trying to be more reactive. But still, with all of that investment across the industry, we still see this average of about 146 days. We are trying to move all of us from a very reactive, very patchwork set of security structures or practices. When you think about it, most companies, most departments, I would bet, most IT shops, build a new security element in response to discovery of a new threat or failure of an audit. Or some chief security officer went to a conference and heard about a new problem and said, we need to deploy this technology. But over time, it's kind of become, I have some firewalls around the data center, or I put some IPSs in a few places, but I don't really know what to do with those IPSs because I can't afford to run everything through them. And so it's a little bit of a patchwork. So I want to talk about the process that I think you'll now go through to transfer from a very reactive, very sort of point solution to a much more holistic set of capabilities that let you really be proactive about controlling the environment. A lot of this has to do with the fact that we will, as an industry, HP and others, right, start embedding the security capabilities you need to understand what's going on in the environment, to be aware of problems, into the infrastructure itself. Instead of bolting on extra devices, and that, I will admit I've sold a few of those extra devices because that was the way we did it in the last decade, right? We threw a firewall at a problem, we threw an IPS at a problem. The problem is that it solves point problems, right? It doesn't solve the point at every place on the network. One of the first things most viruses do today when they come onto a network is not to go try to find the data center, right? Which is where we normally put our firewalls and security devices. Let's go build a moat around the data center. They try to find the other clients on the network. So they go not north-south, they're not working back to the data center, they're working east-west. They're trying to find somebody else to infect so that if they get caught, they live on, right? There's still somebody in the environment. Or when it comes time to hatch, to activate it someday, there's thousands of clients in the environment trying to help them out with whatever their mission was in life. We don't protect networks that way today. If you think about it, if you plugged two people into the same switch in a wiring closet, what stands between them, right? What filters between them? If you're a very advanced organization, you might have something, but I'll be willing to wager everyone in this room, there's my bet, doesn't have anything that keeps those two devices from talking to each other. So how do you do that? Well, what physically does sit there is the network infrastructure itself. So starting to embed some of these security capabilities into the fabric of the network itself. We'll talk about how that's done. And then using those capabilities programmatically, automatically. So the other thing we realize is that if you try to hire a staff of network administrators who sit at consoles and watch for bad things to happen, A, they'll go crazy. B, you'll go budget bust because you can't afford it. And C, they can't catch things that fast no matter what. Right? They don't know what they're looking for, and these things happen in machine time, not in, oh, I see a link with a lot of traffic, let's go enter some commands. It's, well, game over at that point, right? Everything's been moved around the network. So embedding the functionality into the network fabric itself and then programmatically enabling it to find things and automatically respond is the model we're going to talk about. And doing that so you can be effective at blocking things at source, at protecting the data sets you need on the network, but realizing that no matter what you do, or no matter what we do, there is the next technology on the horizon. So as much as we try to protect information, a part of our security strategy isn't necessarily keeping people away from the information, it's keeping them from being able to extract the information from the network. Right? We've built many a data center on the premise that I am going to build that node around the data center. No one's ever going to get to that data. We all know that in the end, that's impossible. You can't spend enough money to protect for every case. What we can do, however, is ensure that if they do get to the data, they can't actually extract it off the network, right? We can make that distributed intelligence, and the network's smart enough to look and say, that file is watermarked with certain code that says it's company confidential. No, I'm just not going to let it flow over this pipe in the network. Yeah, somebody might have gotten to it, started a file transfer, but the network can look at it and say, sorry, I don't care, you, whoever is come onto the network, don't have the rights to do that. Or maybe nobody has the right to do that, right? Maybe it's being extracted over a WAN link to a Starbucks somewhere. Nobody in the company has the right to do that, the last 3 days of a quarter when the financial data is the most restricted. Those kinds of policies to make that barrier effective is where we're headed today. We call this model the Sea of Sentinels. And what it really translates to is taking every element of the network, switches, routers, access points, everything in the network, and embedding within them a lot more intelligence than we've seen in the past in the form of security sensors. So the ability to look for anomalous traffic, basically embed IPS functionality, firewall functionality in the switches themselves. Now, sounds interesting. You say, I can't afford that. You're absolutely right? This is why people don't deploy firewalls and IPSs behind every device today. You can't afford that. Good news is, silicon technology marches along, and what was once something so big that it needed to be in a separate box, today fits in the square, the bottom left-hand corner of a piece of silicon that is the switch silicon. And so the cost for doing these things falls through the floor. The footprint, the physical footprint diminishes, so we can actually now start packaging them inside the switches, inside the wireless access points. The ability to observe strange behavior. When I plug into a network, if I suddenly start trying to ping every IP address adjacent to me, that's not normal behavior for a device, right? The network can see that and say, this is not normal behavior. Let's shut that person off. Let's go send that person off for a little remediation before we let them go do anything else on the network. If I see your PC, try to go to piratesmustdie.com, one of our favorite malware sites in the world. I'm pretty sure you're not really supposed to go to piratesmustdie.com, and I can keep you from getting there, right? By recognizing that's where you were trying to get to, right? One of the things we do is, give you make available a list of all the known all the malware sites in the world, which have engineering teams that do nothing but track those sites in the world. So you can use the network now to help filter that out, to watch what's going on, and then use the management system to drive that automated response. So set the policies. Your job now becomes, what is the organization's policy around security? Is it that no one in a Starbucks or nobody in a coffee shop over a wireless link in a public space can read, HR data? Great. Seems like a reasonable policy. How would you implement that in your network today? That's tough. In the world we head to now of programmatic, we'll talk about SDN next, automated functionality, it's actually a fairly simple step to take, right? Because we'll know users, where they are, what they're connected with, right? What application they're using, and you can set a policy that says the finance team can use Facebook in the lobby on Thursday afternoons. Try to do that in the system today, right? That's impossible. But literally it's as simple as just enter that sentence and you have a security policy going forward. And then in real time, we keep this process updated. So the list of bad sites, HPP may be familiar with Tipping Point, right? The industry leader in IPSs, so our threat reputation database, right? It tracks all the malware sites in the world. So I'm not going to turn this into an HP advertisement, but HP and other companies, right, build these sets of intelligence that help you integrate into this programmatic environment now the automated recognition and response. Right now we have a switch that's smart enough to see that your browser just tried to get to piratesmustdie.com. We can do something about it because you've got the data set that says this is a bad place to go. We see school systems. In fact, a lot of our initial users of this are our school systems, right? This is where the worst case scenario of bad PC behavior lies. But even in the best cases, we see now schools taking that functionality that we originally designed to keep you from going to bad sites and using it for good purposes. So Common Core testing, everybody's favorite subject. When the test starts, this same security capability that kept you from going to bad places, they hit a button and it now keeps you from going anywhere except to the Common Core test server. Right? So they get to decide what's a bad site and what's not a bad site. Yeah, we'll give you the list of sites we know are bad, but if you think Facebook is bad, you put that on the list. Facebook is now a site you can't get to. Maybe it's only bad at certain times of day, or it's only bad for certain people. Maybe ESPN's a bad site, unless you're unless you're the IT manager who still wants to watch Monday Night Football while you're debugging a problem back in the office. Those are the capabilities that, because the intelligence is embedded in the system, and because we have programmatic control over how the environment works, you're now going to have access to fairly simply. So how do we get to that last piece, the programmatic part? Software-defined networking. So as I said, historically, networks were, you configured them once, you crossed your fingers that they worked, you didn't ever want to touch them again because if you had to change that configuration, you were more likely to break it than to make it better, right? The thought of dynamically reconfiguring the network every few milliseconds is scary. But for applications to really work their best, there is no one-size-fits-all setting. For security, for quality of service capabilities to follow users as they move around the network, you can't have a static environment, right? You can't pre-configure everything to work one way because you don't know who's going to be on the network, what applications they're going to run, where they're going to happen to be at a given point in time. And applications can't work well because they don't know how the network's working. A video conferencing application, right? It might think, oh, you told me to run a video chat, right? Link, Microsoft Link video chat, simple thing. If it knew that the link between the two of us was completely congested, it would pick a completely different codec, a completely different video resolution to run that session with, instead of starting with the blind guess of, let's go with high res, and then we get, what you get when the network's congested, but the application's ignorant of that. So the ability for the two to talk to each other can dramatically change how the application actually performs, and certainly how the customer, the end user, perceives that application performing. This is done. I won't go too deep. I'll stick around afterwards if anybody wants to get into the depth of how SDN works. But the simple model you will hear is we take the world of networking from a standard or traditional network management view of you go in and configure devices to a separation of the control aspects of the network and the enforcement aspects. Today you go configure a device, right? You manually got in there. The control of the device is built into the device. And you type it a CLI or the network management station, you configure it. In the world of software-defined networking, we separate those two functions, right? So we'll talk about this control function. See here, right? Really separated from the infrastructure devices as the place where applications or policies can all talk to a common point in the network, and then it deploys based on that dynamic. Bob's over here now, no, he's over there now, right? So I need to reconfigure the network so that his link traffic follows him, or his link traffic has the right priority over where he's at. Not an IT staff person sitting there trying to reconfigure, port level quality of service attributes, which of course would never work. So that agility is derived from an open standards-based, this is one of HP's religions, right? Open standards-based infrastructure devices. So you'll hear words like open flow, radius, the protocols that we use to communicate between the controller and the individual devices. The controllers themselves, so you hear people talk about an SDN controller. The industry is working toward a standardized model. You may hear Open Daylight. It's the consortium that's trying to build a standardized version of a controller. And most importantly, the applications, right? This is the place that we ignored historically. Application developers, by and large, have no concept of networks. Network managers, by and large, have no concept of applications. One of the things about this model tends to be, for network administrators, wait a minute, the controller's going to do all that network configuration? What happened to my job? The thing we always remind them is, so your job just got more important, right? Your job is now to go sit with the application developers, because you're the only person that understands the network, they don't, and talk about how we build now applications that do comprehend the network, that do take advantage of it, that are able to express their needs down into the network. And it's done through a nice open set of APIs, so that part's the technology that's easy. It is the comprehension of an application developer to even think now that the network is something they can converse with, that they can affect, they can change how it behaves. That is not in their DNA today. And so it's going to take the best and the brightest of our network administration staff to go partner with them. I don't want to say that it's easier to teach a network person's applications than an application network, but it is. At least that's my story of all the networking people in the world. And so that is the journey that we're going to be on to get that level of agility, because otherwise we're right back to it's a static, fixed environment. Yeah, maybe we made it a little smarter, but you're still not going to be able to give the user that experience they're looking for. The application still won't be able to customize for them. An example, we have a number of customers in the retail industry, right? So you will be affected by this before long, right? Who now are working in the application that if you're a member of their rewards club, you're strolling down the aisle, they know you have a history of buying Captain Crunch, and you're in the cereal aisle. They know who you are, they have your phone information. If you're using the in-store Wi-Fi, you've had to check the little box and say, I agree to terms and conditions to say you can track me through the store. Wow, as you turn into the cereal aisle, your phone vibrates and there's a Captain Crunch coupon. How'd that happen? Which would probably incent you to buy more cereal instead of walking past it and forgetting about it that trip. So this ability for the application to take advantage of things the network knows, and the network to take advantage of things the application wants to do, is going to drive a lot of new capabilities. For some organizations, that's going to feel like new revenue opportunities, because they're here to create new services. For I think most companies, when we think about our own employees, it's going to create job satisfaction and productivity. It's going to enable people to do things faster, because there's somebody assisting them in the process of whatever they were trying to do, right? Understanding who they are, where they are, what they're trying to do, and adapting how all the communications infrastructure works. So, same kind of network picture, but now you'll see smart devices at the bottom, right? So these are your switches, APs, routers, etc. This thing we call an SDN controller, which really just bridges between applications and the devices. So your application developers will never have to learn how to talk to an HP switch, a Cisco switch, somebody else, right? They will learn a programming language. They'll learn an API just like they do for any other bit of programming. That controller is the thing that will translate the request from the 15 different applications that are running on your network at that moment, or the 1,000 different applications that are running, into commands, into policies that get executed, right, down at the individual infrastructure devices. So, an example. So let's take an integration of security and an SDN. So an application that we're shipping today, but just as an example to help you understand what SDN can do. So we call this Network Protector. So this is the application that, as you come onto a network, the network, you have to authenticate to the network, right? Don't care if you're a guest, however, you're at some level you're going to authenticate onto the network. Regardless of how, in this case, we watch the requests you make onto the network. So every time you go to a website, you make DNS requests. You try to figure out where that website is. We dynamically intercept these DNS requests and run them against a filter in the switches that checks that site name against that reputation threat database the tipping point creates, and says, is this a known bad site? Or have you deemed it to be a bad site, right? That list is editable by you. Maybe it's Facebook on that site, on that list. If it is, we block that traffic. We don't let you go to that site. Your application, or perhaps your virus that was trying to phone home, right, and get its updates to figure out how to deploy, thinks the network just has a problem, right? It doesn't know we ate the traffic. It just times out and sits and waits. You can leave it that way because, frankly, for a virus, that's how you want to leave it. Or if you see some other things going on, now you see it do something else, trying to contact a bunch of local addresses, launching some other application that you say doesn't belong to that person, right? We correlate those events, walk that person off the network, bring the screen up that says contact your IT staff, they're waiting for you to clean your PC, or whatever you want to put on there. Shame on you for doing whatever you did on your PC Tuesday night. But it happens automatically, right? It happens in real time, and it happens for every single device on the network, right? Simultaneously. So this is not a, we do this one, then we do this one, right? This is every port on the network now has this capability. And it's automated. You still get to set the policies. And that will become the next major challenge for most of you in terms of managing the environment, right? Where before it was, how much bandwidth do we need? How much budget do we have? Now it's going to be, well, is the finance department allowed to use Facebook in the lobby on Thursday afternoons? Or not? Or is everybody allowed to watch ESPN all day long? Those will become the policy questions. And then when you get to the next tier where people are actually writing applications or modifying applications to be intelligent on the network, you will get the inevitable, well, now that people are trying to utilize the infrastructure you paid for, who gets to decide, what their priorities are? Is the payroll application more important than the application that monitors the power grid? Well, maybe it depends on when it is. Maybe, on the 15th of the month, if it's a weekday at 3 a.m., the payroll application gets priority, but the rest of the time, the power grid monitor gets the priority. Those are the kinds of policy decisions that your organization is now going to get to play with. So apologies for helping and making life more painful at the same time, but at least now you're going to get to have conversations with I'll just use the generic term, the business leaders, right? It's no longer about technology, focusing all your attention on keeping it running. It's about bringing value add to your line of work, to whatever your organization's mandate is, right? How do you help them do a better job of it? How do you help them be more productive, more efficient, deliver a richer customer experience at the end of the day? You're going to see this work across every application, right? So another application example we have, we call it Network Visualizer, that helps you troubleshoot problems. So today, if that link chat person we talked about earlier phones the IT help desk and says, I'm having a horrible video session with John, can you fix the network? Okay, so Bob and John are having a video chat session. I have no idea where Bob and John are. And you ask Bob, so what's your IP address? What's your MAC address so I can find my what? I'm down here in the maintenance shop trying to figure out how to repair this generator over a video link. What's my what? So that conversation's not going to go very well. The world we'll now live in, though, of the network knowing who you are, where you are, what you're doing, what applications are, not in a big brother way, right, but in a I'm aware of, and now let's use that information. You can simply say in this application, mirror Bob's link video traffic to the following location. You can get now a copy of that real time and look at it and say, I can see what's going on, right? My pick your favorite, a monitoring tool looks at it and says, I see a bunch of packet fragments, so I know that means we've got this kind of problem. I see long inter-packet gaps, we've got a latency issue, this is the kind of way we're going to solve this problem. But it gives you the tools now to go find that information, and it's all based on the same notion of software-defined networks, right? The ability to have policies, pushed into the network dynamically in a programmatic, from an application, in an automated way dispatched when you try to implement a policy locally. So that ecosystem looks a lot like current network technologies, except you now see these controllers out there, and you're going to see a growing number of applications that take advantage of this. You will write some of those applications yourselves, but you're going to find all of your software suppliers headed in this direction as well. So this is a small set of the people that are currently on our app store. It's not the kind you go on your phone and you download, some bird game. But it is an enterprise class with a PO number. You can get a copy of an application, or you want to play with an SDN app, you can download a demo copy. It's a storefront, right? Let people go kind of see what's out there. But literally everyone in the world is beginning to build these applications or build the enhancements to their applications so that they take advantage of this new capability. Your software suppliers want to differentiate their product, right? How do they do that? By delivering you some more capabilities that you can't get from other people, right? So they're naturally going to rush this direction. It'll be your in-house application developers, right? That there's probably a little more education, a little more tugging of, is it worth, making this investment versus whatever was next on the enhancement list. And in the end, as a result, we're going to get a very different mobile campus environment than what we've been used to, right? We're going to see this single approach to wired and wireless. So all those security things I talked about, all the software-defined network things, hopefully I never actually said wired or wireless, right? Because they apply equally across the board. You're going to get those services, right? That ability to embed security capabilities, to dynamically deploy an IPS wherever you happen to need in the network. All of those capabilities now be programmatic. They're not dispatch somebody to go rewire a wiring closet to move a firewall from point A to point B, right? We'll just tell the network, route the traffic through the firewall. And it'll go out and route through the firewall and back, and the firewall never moved, right? So the ability to move quick, to make changes fast, whether application-driven or security event-driven, is what's ahead of us. I think this is the promise of a much more business-impacting network, not just simply the, I hope it stays away, alive today, which is not the environment we want to live in. So you're going to see products from HP and from others, right? I think you'll find that HP certainly on the bleeding edge of driving this. We started to work with Stanford University about 10 years ago to pioneer down the software-defined network path. And so our switches, our applications are a step ahead of most of the world. But you will find this from all your vendors, right? Don't let us off the hook. Don't let any of your other vendors off the hook by not asking the question, right? Is this switch OpenFlow enabled, right? Will it work in a software-defined network environment? What is your application strategy for me, Mr. Software Vendor, to take advantage of this? Those are the questions you need to be asking today. And if you need help figuring out how to ask those questions, right? I think this is another one of those places HP would love to help you. Just our consulting organization who will come in and do simple transformational workshops just to help you lay out your path from today to tomorrow. Because tomorrow is a mobile world. Tomorrow is an application-driven world. And tomorrow better be a secure world. Where none of us have jobs. Because nobody wants to trust an environment, work in an environment that's, it's not making them productive and not leaving them feeling secure at the end of the day. So with that, I want to say thank you very much. It has been a pleasure to chat with you, and if I can answer any questions afterwards, I am happy to. But thanks, and have a good lunch.